A, if we're going to name this as a phenol, that means this substituent is already taken care of, and that locks this as carbon 1. So I number around the ring to reduce the number of our next substituent, so this is a 3-bromophenol. Now we can also name this with the ortho-meta-para convention, and this is the meta position, so this would be meta-bromophenol. B, as an aniline, if we're going to name it as an aniline, that takes care of this substituent and locks this as carbon 1, so this is carbon 2. So we have 2-fluoroaniline. Ortho-meta-para system, this is the ortho position, so this is ortho-fluoroaniline. C, as a benzene. If it's a benzene, then we're looking at chlorine and methyl as our substituents. Now I can number this way, or I'm going to change my colors just to show you a number on the inside. I can number this way. Either way, my substituents are at 1 and 4. Therefore, the convention is that in alphabetical order, because I have chloro and methyl, and in alphabetical order, C comes before M, then chloro is going to get the lower number. So this is 1 chloro, 4 methyl benzene. Now, ortho-meta-para position, they are para to one another, so we would call this para-chloro-methyl-benzene. Now, D, if we're going to name it as a benzoic acid, that takes care of this substituent. It also locks this as carbon 1. And because of that, we can number around this way. So we have substituents at 2 and 5, or we can number this way, 1, 2, 3, where we have substituents at 2 and 5. So now we need to let alphabetical order rule. We have a methyl and we have an amino. Because amino starts with an A, which comes in the alphabet before M for methyl. This is 2-amino, 5-methyl benzoic acid. E, as a toluene. When we name a toluene, we've taken care of the methyl substituent. That locks this as carbon 1. So that'll make this 2, 3, and 4. We have a 4-amino here, and we have a 2-fluoro. Now, if we had gone the other way with our numbering, that would make this 4 and fluoro 6, because 2 is less than 6. We're going to go with the original numbering, the counterclockwise numbering. So this becomes 2 fluoro, 4-amino toluene. For F, if we name it as a phenol, that takes care of this substituent, and any which way we number it, it becomes 2 and 6-dimethylphenol. So that is the name for F, 2,6-dimethylphenol. G, if we're going to name G as a benzene, that takes care of this parent ring, but then we have everything else. So we have a hydroxy, we have a bromine, and we have a pentane. Now, purists may look at this and call it N-pentane. And frankly, I would. I guess that makes me a purist. I'm going to have to reread on IUPAC to see if they have changed the guidance there. But these are our substituents. So if we're naming this with benzene as the root, then this becomes a 1-bromo, 2-hydroxy, 4-pentyl benzene. H, if we're going to name H as toluene, that takes care of this substituent that makes this carbon 1. Here's 2, 3, and 4. So we have 4 chloro, 2 hydroxy, toluene. If we're going to name I as a benzene, then we have our two substituents here. We have a chloro, and then we have this group here. Now this group is an isobutyl group. And this, of course, being chloro, we're going to give chloro the lower number. So that would be 1 chloro 3 isobutyl benzene. J, if we're going to name J as benzoic acid, then that takes care of this and locks this as carbon 1. So then we have 3 bromo benzoic acid. Now this is also ortho, meta, this is also the meta position. So you could call it meta bromobenzoic acid, all the same. If we're going to name K as a benzene, that takes care of our hexagon. Now we have nitro, we have fluoro, and bromo. So all things being equal, we're going to yield to alphabetical order. This will be 1, this will be 3, and this will be 5. So 1 bromo, 3 fluoro, 5 nitro benzene. And finally, we have L. So how are we going to name L? Well, we have this carbon chain here. And this carbon chain has two substituents. It has a phenyl group and a bromine. So we want to reduce the address of our substituents. So if we go this way in orange, we would have 1 and 5. And if we numbered this way, we would have 4 and 7. So because 1 and 5 are less than 4 and 7, we're going to go this way. So this would be 5 bromo, 1 phenyl heptane.